Great.
Right, who have we got next?
Yeah, so moving on, we've got Dr. David Parker. He's the Director of Human and Robotic Exploration at the European Space Agency. He's going to give us a quick presentation, and then we can have some questions. So please fire your questions out. We'll see them in the Q&A box, and we can ask them at the end.
David, thank you very, very much for taking the time to join us. David, are you there?
Yeah, do you hear me?
Hey,
Fantastic.
Thank you very much.
It's a great show so far. I really enjoyed it. Great job.
Good.
Well done.
Good. Thank you. It's all yours.
I hope some lovely person. Oh, maybe I'll share my own screen. Is that the idea? Or can you share it for me? I don't know.
And hopefully we'll scroll down. We'll get some probing and difficult and interesting questions for you later on.
Yeah. Cool. So do you see my screen okay?
Yeah,
Yes, we can. Thanks, David.
Fantastic. Okay, so well, good morning and to everyone. My name is David Parker. Yeah, I work at the European Space Agency, and it's my delight to have a chance to talk to you about our exploration program as a whole, and that will sort of explain where Mars fits into it a little bit. So I'm going to explain what I mean by space exploration, show what we're doing in Europe together. And again, as others, Susan has just done really well, convince you that maybe you have a chance to be a space explorer as well. So, but I better start by just explaining what the European Space Agency is, by explaining it. So this is our purpose in life. If you could summarize it as being, we bring space to life. We do every kind of space activity that in the world of civil space that's possible. We're European countries working together, and we've been doing it now for more than 50 years. There are 22 member states, in fact. There are also some more associated states. You'll see on the flags on the bottom, see if you can recognize how many of the flags, but you'll see the Canadian flag there. We also work with Canadian friends as well, Canadian Space Agency. And very roughly, we spend about I would say €10 per head of population in Europe. Something like that. We're built about 100 satellites designed and operating in space. And the bit that I'm responsible for, which is the space exploration program, is about €1.20. So what's that? About £1. So I guess that buys you a couple of Mars bars per year, something like that. So we are, as I like to say, a full service space agency. As Sue Horn was explaining earlier, there are lots of different types of space activities. And globally, actually, by far the most important one is very practical and down to earth, and that's information and services from space. So that the space industry around the world is worth over $300 billion per year. There are 3,000 satellites up there that are operating today, but most of them are doing communications of one sort: voice and data, television broadcasting, of course, internet services to remote areas, all of those kind of things. But also weather forecasting. And, the UK Met Office says that 2/3 of the accuracy now of the weather forecast is thanks to the data that comes from satellites. So satellites as one type of weather forecasting is one type of Earth observation. So other types of Earth observation, I think Sue mentioned about use in agriculture, urban and rural planning, all of these practical uses, but also responding to disasters before and after. What happens, providing imagery to support the emergency services, disaster relief services. And really the unique vantage point of satellites, 365 days a year, is really important to gather data about our planet as a whole. So Europe's Copernicus Sentinel satellites are working 365 days a year, gathering information about the land, the sea, the atmosphere, the ice caps, and how it's all changing. And so a lot of people are concerned about climate change, of course, but the IPCC, the people who monitor all of this, say that there are 47 essential climate variables by which we're understanding. These are the little markers, the information about our planet, and more than half of those we only get from satellites. So satellite data is really vital for understanding the changing climate. And there's also all the everyday hardware that's, if you have maybe a smartphone, inside there's a piece of space technology. It's the space tech that's taking the data from the Galileo and GPS satellites to allow you to navigate, find your way around town, or even use to safely land an airliner these days. So those are all the practical uses of space, but I'm going to focus on the outgoing exploration of space, the space science and space exploration, give you a few examples of things that have happened in the past, some things that are happening right now, and what's coming in the very, very near future. And I always say that exploration in particular is driven by a combination of curiosity and opportunity. The curiosity to go out into the unknown, and the opportunity to bring back to Earth discoveries, perspectives, ideas you only get by going into the unknown. So when I say science and exploration, I mean things like the incredible journey of our robot explorers. Here's one that ESA did back in 2005, was to make a landing on the most distant landing on another planetary body, on Titan. Extraordinary world around the moon, around Saturn, another world, more than 1.4 million kilometers from the sun, a journey that took years to get there, and discovered a world with riverbeds and lakes and everything you might expect, but it's not water, it's hydrocarbons, it's methane, frozen at very, very low temperatures. So an extraordinary discovery within the scientific program. Another mission that happened a bit less than 10 years ago now was a mission to a comet, where we made a landing and rendezvous with the comet far out in the solar system after a long journey. The first landing, another ice world, and searching again for water or other chemicals that might be the origin of life. A lot of what drives us in our space program, the scientific program, is understanding the mystery of life. Life on Earth is everywhere. The whole planet teems with life. Is that just a chance? Is that a unique thing, or has it happened somewhere else in the solar system and in the universe as a whole? And how did life start back here on Earth? Another mission that I find really exciting, next few years, there'll be this mission, BepiColombo, which is on its way to our hot planet close to the sun, Mercury. So it's using UK-built ion drive propulsion, electric propulsion. It's launched in 2018, and it'll take 7 years before it finally gets into orbit around this strange hot planet. But it's also a cold planet, because there are parts that get incredibly cold because they don't see direct sunlight. So our spacecraft has to survive this fantastic heat to get there, and also to function. We're working, again, a perfect example of international cooperation with our friends from the Japanese Space Agency on this really exciting project. So that's on its way to Mercury. Next year, we'll launch our mission to the outer planets, to going to the Jupiter and its icy moons. This mission is called JUICE. So it's going to study fascinating worlds, the icebound worlds of Jupiter, so Europa, Callisto, Ganymede, which we think has volcanoes that are active there right now. But we have to be patient, and that's something we have to be with space programs. We launch next year, but we won't arrive until 2029. Now, all of these missions I've just been talking about are kind of one-way trips. They're going outwards, but they're not coming back again. And for me, exploration is very much about going there, but also coming back with the stories we have to tell. And so it's focused on places where humans will one day live and work. And that's where we're already living and work off-world on the space station, and have been now for 20 years. And the other places we want to go to have the same potential, and that includes Mars. So I always like to start with going back in time, history. Historical analogy, we always talk in Europe about the old explorers, voyagers like Christopher Columbus. I'm speaking to you today from my home in Bristol in the west of England. We celebrate an explorer called John Cabot, who made a journey in 1497 across the Atlantic Ocean to a place we now call Newfoundland, the Newfound Land, which is now part of Canada. And his little tiny ship shows the kind of courage of sailing across the Atlantic Ocean in an unknown worlds, to seek out unknown worlds more than 500 years ago. But I like this picture because the little sort of red dotted line showing his route map reminds me of the typical elliptical shape of a mission from one planet to another planet, from going Earth to the moon or going to Mars. We go from one orbit, one planet to another in elliptical road maps. Now, that's exploration in the past. This is also exploration in the past. Maybe the pinnacle of exploration, space exploration, certainly, the Apollo moon landings between 1969 and 1972, so long ago. that it's kind of ancient history to some of you, I suppose. But I'm so old that I remember it. Like, to the 6-year-old me, the moon landing in 1969 was the most exciting thing that had ever happened. But you may ask, why did we not stay on the moon? And why aren't there even humans on Mars yet? I mean, after all, Matt Damon made it look quite easy when he did his movie, The Martian, a few years ago. But I want to emphasize the opportunities for being space explorers by showing this picture, which is one I really like. This is from the last Apollo mission in 1972, so exactly 50 years ago. That's a scientist at work, Harrison Schmitt, or Jack Schmitt. He was the only actual scientist as opposed to test pilot that went to the moon, and he did some great work. But again, the question is, this is a long time ago. Why did we not stay at the moon? What has happened since then? So let me tell you a story, a personal story. So I go back to 1971, and in those days, most of the tea you drank in the UK came in little packets about this big. It's loose leaf tea. Tea bags are a bit new and a bit fancy. But back then, for more than 20 years, the main brand of tea in the UK, they put a little picture card into every box of tea, and you 50 on a particular subject, and you collected those. So there was a series on ships and birds and inventions and famous cars and all that kind of thing. But in 1971, the series was about space, the race into space. What you did, you got your 50 cards, and then you stuck them into a little album and you kept them. And I've still got my cards. I've still got my album that I made in 1971. It might sound a bit weird to you now, but we were happy back then. So this is what it looked like. This is the outside of the little book. It cost a whole 5p to buy, 5 pence to buy the book. And the first of the 44 cards in that album told the whole story of space from the dawn of the space age, 1957 in Sputnik, up to the moon landings in 1969, 1970. But it also looked to the future, and it looked to a future where maybe we build something called Skylab, which was the first space station. We build something called the Space Shuttle, and we built something called Grand Tour that became Voyager. What's Voyager? Voyager is a couple of US explorer satellites that left in the mid-1970s to explore our solar system and have now left the solar system completely behind. We're still in communications with them, and they may be the last thing remaining of humanity when life comes to end on this planet in millions of years' time, because those spacecraft are sailing out into the universe and will travel forever. But the last thing that was in the picture cards was the human mission to Mars. And I don't know if you can see this, but the plan was to leave in November 1981 and to get to Mars in 1983 and come back by the end of 1983. So that sounds very exciting. It was very exciting to me as a 7, 8-year-old, but it didn't happen. It just didn't happen. And the reason why it didn't happen is this: it's money. It's money that drives a lot of these things. I promise this is the only graph I'm showing you, but it shows you how the budget that NASA had for space exploration actually had already reached a maximum in about 1967, and it fell a lot after that. And it's much less now compared to the amount of money they had in the 1960s. So that's bad news for me dreaming of missions to Mars and going to the moon and all of that. But, and this is the point of the story, it's all about working together. The exploration we do today is very much about working together, and the International Space Station is a perfect example of this. So it was built by all the countries, United States, Canada, Russia, Japan, all the countries of Europe were working together, and it was bolted together above the space there, above us, above our heads, for the first time, building above our heads at 400 kilometers. And it's being continually occupied now for 21 years. So it's a place where dozens of astronauts have carried out hundreds of experiments on behalf of thousands of scientists around the world. And it's also a stepping stone to go a bit further. So we keep talking about exploration. Perhaps I ought to say, why do we want to explore? It's for good reasons. I've just given one of them, which is international cooperation. But new knowledge and science is really, really important. And while our program in Europe is focused on exploration of low Earth orbit, going forward to the moon to really do explore the moon, and then Mars, because Mars is a place of immense scientific interest and potential because of what it might tell us about the history of life in the universe. But science is not the only reason to go there. The technology, and this is again something that Sue Horn said earlier, it's the ultimate place to develop new technologies, efficient energy production or robotics or life support systems. And so we bring all of that knowledge back to Earth. And I give you a simple example I always use. You and I, in our homes, use about 100 litres of water every day. On the space station, with recycling and being very efficient, the astronauts only use 5 litres of water a day. But if we want to go to Mars, we can't take all the water with us. The journey is at least 6 months, maybe 9 months to get to Mars. So we need to do even better technology in recycling. And so this is what we talk about, developing the circular economy, where we can recycle everything. And doing space exploration, we have to develop these technologies to do it. But having developed them, though, we can use them back here on Earth. And the ISS, and that's the little picture on the top left there, is our orbiting laboratory aboard the space station, is where we do this kind of work. And funnily enough, it's called Columbus. Now, then the astronauts themselves are kind of embodiment of these ideas of working together, using science and technology to solve problems and bring the benefits back to Earth. So you may meet a guy called Tim Peake, who happens to be one of my astronauts, who did a mission a few years ago. And I have another one of my colleagues, Matthias Maurer, who is aboard the space station right now. He's already spent 100 days on his first mission to the space station. So our exploration program is focused on these 3 destinations. This is the where we're going. So let's take a moment to look at these 3 destinations, and the 3 locations are very, very different. And I hope you can see that this picture is a lie. First of all, it's a trick, because of course the Earth, the Moon and Mars are nowhere near the same size as each other. You can see the different sizes, the diameters on this slide. But less obvious things are the different gravity field and the fact that we are protected on Earth by a magnetic field that protects us from the radiation of space. And that same is true for the astronauts aboard the space station. But when we go farther out into space, we have to think about protecting ourselves from the space radiation environment. But the most important thing is really the distances we have to travel. And I don't know if you can see me holding up my hand now to make my 2 hands to make a kind of globe. So if that globe represents the Earth, then the distance where the space station is off the Earth is about half a centimetre. It's about the length of the hairs on the back of my hand. So it's not very far away into space is where the space station is. Where's the Moon? Well, on the same scale, if this is the Earth, then the Moon is about 4.5 meters away. So it's about 380,000 kilometers from planet Earth. So where is Mars? Well, of course, Mars is going around the Earth, or going around the sun the same way as we're going around the sun. And so at different times, it's a different distance away. But when it's very closest, it's about 1 kilometer away on this scale. So this is planet Earth. And when it's the most distant, it's something like 5 kilometers away. So the answer to my question, why aren't we at Mars yet? Why aren't humans at Mars? Is very simple. It's a long way away. So we need to get there in steps, learning to live and work in a sustainable way. And so this is a very busy picture about our space exploration program in Europe, a lot of it done in international cooperation, and we call it Terra Novae. It's Latin, it means new worlds. New worlds literally are places we're going to, but also new voyages and new possibilities and new opportunities. And so this picture is a really nice one because I hope you can see it's a multi-frame image of the space station traveling around the Earth, but passing in front of the distant Moon a long, long way away. It gives you the hint that we're on a journey that goes from low Earth orbit to Moon and to Mars, eventually with humans. But the Moon is really exciting in its own way. I like to say it's a museum. Our solar system is 4.5 billion years old, and the Moon is a kind of a museum of 4 billion years of that history. But so far, we've just went to the Moon, this museum, a bit like going to the museum gift shop, just grabbed a few souvenirs. We were there for a few days, we came home again, and then we've left it behind. But now, and you're so lucky to be living in this time, now is the time we're going to go back and to focus on living and working there for a long time. And we call this program the Artemis program, and it's just about to happen. So we talk about going forward to the moon, and here's a picture of our new, and one of the reasons we want to go there is because we learned a lot more about the moon than we used to know. And we now believe there is a lot of water in the poles stored in the soil and maybe even as ice in the craters deep in the south pole of the moon. And that's important because water is life, could be life for our astronauts, if we can even maybe turn it into rocket fuel to go further into space. So this is one of the reasons we're going back to the moon, and this is the rocket we'll use to do it. This is the new Space Launch System. If you look very closely, you can see this is just a CGI, it's an artist's impression, it's not the real thing. Here's the real thing. This is the Artemis 1 rocket in Cape Kennedy in the giant vertical assembly building, photograph taken last week. And the point of it is to show you that ESA is aboard, European Space Agency is aboard this mission. If the first test flight will happen in the summer of this year, it'll be uncrewed, but the second mission, Artemis 2, will be 4 astronauts aboard. And because we're part of it in Europe, there will be European astronauts flying into space aboard this rocket. And so it's great to see the NASA logo and the ESA logo together there. And what is Europe doing? Well, that sort of metal white drum thing may look a bit boring, but actually behind it is the power and propulsion that will take humans into deep space aboard the spaceship, and it's called Orion. Orion is the human spaceship that's part of the Artemis program. So where will it, we're very excited about this, and it's the first time that ESA in Europe is really part of NASA's top space program. So it means that ESA astronauts will fly to the moon. Where will they fly to? Well, the first thing we're doing, and I keep saying we want to go there and stay at the moon, is to build a permanent spaceport around the moon. We call it the Gateway. It'll be a research outpost of its own to allow us to do scientific research, but it's also a kind of spaceport for sending landers down to the surface of the moon. It's going to be very exciting because we're building some of the modules where the astronauts will live and work around the moon, and we're also building some of the technology and the science, but also the windows. So it's going to be an amazing view, be able to peer down from the gateway from our space station around the moon down to the surface of the planet. But the long term we want to do is to build a permanent, sustainable presence on the moon. So build a moon base of some sort, and in a sense, do some of the things that we were talking about 50 years ago. And this gives you an idea of some of the work that we've been doing in Europe to design a moon base. And remember, I was talking about the radiation. So the idea is we 3D print lunar soil to make bricks that we can put over the surface of our moon base to protect from that radiation I was talking about. But we don't want to leave it there. This is the Mars Day, and we are on our way to the red planet. And it's definitely our horizon goal for astronauts as well. So this is pictures taken by Europe's first Martian explorer. This is Mars Express. It was launched in 2003, and it's still doing great work. It's still producing great imagery. It was the first step in our program. Now, Sue Horn mentioned the ExoMars Trace Gas Orbiter already. Again, please go and look at the amazing images that this spacecraft has been sending back. But it has also told us that there is a lot of water on the moon, on the Mars, excuse me, below the surface and in the frozen ice, polar ice packs as well. So it's a really exciting project. Sue also mentioned the Rosalind Franklin rover. So this is a mission to really search directly for life. And one of the talks later today is by one of my colleagues, Jorge Vargo, who's a brilliant scientist, who's knows 1,000 times more about the history of Mars than I do. But my simple explanation of why we wanted to go there is, as Sue said, when Mars was formed and in its first billion years of history, it had all the same raw material as planet Earth. Life got going on planet Earth very quickly in the first billion years, and it's been going from now for 3 billion years or more. So did life start on Mars, and was it like life on Earth, or was it different? The challenge is today, we just don't know. We have to go there and find out. As Sue said, one of the steps on that way is not only to go to Mars, but to make a round trip with Mars sample return, really the most ambitious space mission ever attempted. Again, some NASA and ESA colleagues are going to talk to you more about Mars sample return, so I won't say much more right now. But all of this is really preparing us for that ultimate goal of sending humans to Mars. I think by about 2040, we'll be able to do it. And as a result, all of the things I've been talking about are the steps towards the things I dreamed about when I was a kid, thinking about space travel. So the message again is study hard and dream hard, because who knows, you might be part of this story. But it's not easy sending humans to Mars. There's a lot of work still to do. It's not, I don't just mean building a bigger rocket. Building a rocket is a challenge itself, but how are the astronauts going to survive the journey? How are they going to, the journey might take 3 years there and back. How are we going to give them the oxygen and water? How will they live together alone for 3 years? So there's an awful lot of things we need to do. We do a lot of this research back here on Earth, and we're doing it right now. So for example, we can learn to be Moon and Mars explorers, not only on the International Space Station, but even on Earth. And this looks like Mars, but it's not. It's somewhere in Spain, Lanzarote. So here's our space scientists and space geologists learning under the Spanish sun how to explore Mars. And we're also doing it by sending doctors and psychologists even, and scientists to the remotest place on Earth. So this is the Concordia station in Antarctica, and we have scientists there doing all sorts of work to prepare us for Moon and Mars exploration. And here are some of those scientists. It doesn't matter what they're doing, but they're all young people that are developing skills and developing the ability to make us survive on a hostile world such as Mars. And in everything I'm doing, I also talked about the fuel and the oxygen that we need on another planet. So here's two of our scientists, Beth Lomax, who happens to be British, Alexandre Maurice, who happens to be French. They've been testing a way to extract oxygen from the lunar soil, oxygen we need for rockets, oxygen to breathe, oxygen to go further, maybe to Mars. So again, as Susan was saying earlier, as I come to the end of my talk now, everything we've been talking about, UK scientists, UK engineers, UK technicians can be part of it, even lawyers and financial experts. The UK is really part of this grand endeavour that is making history through being part of the European Space Agency programme. So my very last point is to come back to another personal perspective. As I said earlier, I'm so old that I remember the Apollo moon landings, and I was given for Christmas 1969 a book based on a kids' TV program called Magpie. Maybe some of your teachers are so old like me that they can remember that. But in the book, it says, in the front page, it says, the exploration of space is probably the greatest adventure in history. President Kennedy, who started the Apollo program in 1962, said, we are set sail upon this new sea because there's new knowledge to be gained and new rights to be won. And the book says there's much to be learned about this new sea, and new knowledge is being gained every day. There may be some readers of this book who will be lucky enough to take part in the gathering of this knowledge. Well, it's been my great fortune to contribute a little bit towards this new era of space exploration. But I'm sure that some of you will play your part in the future as well. So thanks very much for your attention, and thank you for giving me the chance to talk to you today. So have a great Mars Day, and stay curious and keep exploring. Back to you.
David, thank you very much. You're not old, and I can prove you're not old because I also had the Brooke Bond T cards, and I'm really young. So I mean, that means you must be. It's really funny actually talking to people how important things like books and films and television programs were. Any sort of scientist I talked to, it's always the film I watched, or I used to watch Tomorrow's World, or I had a particular. This was a book that I had, which similar to your Magpie book, which I absolutely loved. It was mainly the pictures. Actually, I look at these pictures, I'm like, wow, that looks incredible. Actually, one very quick question, Mr. Poole. I'm not sure where Mr. Poole is from, but he wants to know: are you interested in going into space yourself?
I always get asked that question, and I've always been the geek. So I've never wanted to actually be the explorer. I want to build the rocket and send the people out there. I'm not brave
good
enough.
answer. Good answer. Actually, we've got another one on that note. Someone asked us, how much does it cost to build a spaceship? I think it depends on the spaceship, but any numbers you'd like to give us?
Well, yeah, I mean, you can build satellites for as little as about 50,000, something you can hold in your hand, and our grand missions to Mars is more like $1 billion.
Okay. Well, actually, one of the David, one of the projects that you mentioned in your sort of sum up of all the different things that ESA are doing is BepiColombo, and you work on BepiColombo.
Yeah, I do work on BepiColombo, on its way to Mercury at the moment, and we're really looking forward to it arriving in December 2025. So only another 3.5 years to go.
Yeah. How much does it cost?
Not so bad. A lot of money.
Okay, yeah, a lot.
Maybe we won't put numbers on.
What actually is a really interesting thing is a lot of these space missions that we talk about, particularly actually you mentioned the Grand Tour, David, the Voyager missions. Scientists spend their entire careers working on one particular mission because they simply take such a long time to.
Well, at the moment that's true, and maybe David has some thoughts on this. But you know, from my perspective, perhaps the future of space exploration maybe isn't missions that take 25 years to design and build and launch. Maybe we're going to move towards a different style of mission where we've got cheaper rockets and cheaper spacecraft that we can build much more rapidly. What do you think, David?
Yeah, I think it'll be a mixture of both, to be honest. I mean, if we want to send humans to Mars, that's going to be a big expedition, but we can send very small satellites to do very cool things at the moon and Mars, and we're doing that right now, even these little CubeSats that you could hold in the palm of your hand. So yeah, you're absolutely right. It's a really exciting time.
And there's loads of opportunities. Anyone out there interested in CubeSats to get involved in various things. We talked about some of the competitions that are available. European Space Agency offer competitions.
Yeah, schools are kind of designing satellites that fit in Coke cans and doing like amazing, incredible things. And it's interesting to point out, important to point out that the entire infrastructure of sort of modern life on Earth is dependent on space technology, really, whatever it is, whether it's communication or GPS or all of these things. We need bright people to be working in the space industry. We've got a couple of minutes left. Actually, I'm interested, David, one question I had. You've had such an extraordinary career and you've got such a brilliant job. Do you have a particular moment in your career that stands out for you as your kind of, that's my proudest moment? If I could sort of pin one moment in my career on my wall and frame it, what would it be?
Well, I was involved in helping make Tim Peake's mission happen. So being at the launch site on that day was an extraordinary moment. It was a culmination for me of 10 years of work, one way or another. So that was a very special day.
I agree, and I remember in the Science Museum. I was at the launch. I was at Baikonur with him, so I missed all the excitement. But I remember seeing the pictures of all the kids, the young people in the Science Museum, just shouting and cheering.
It was brilliant.
And I hope that will be their Brook Bond moment, their Brook Bond tea collecting card moment. And